In this video, I go over the first problem in exam 2. A 30.0 kilogram block is pushed over a rough horizontal surface by a force F sub p equal to 60.0 newtons, acting at 25.0 degrees above the horizontal. The force F sub p is just enough to keep the block moving with a constant speed. In part A, we're to draw a free body diagram of the block. Make sure to break up all of the forces into components. So just looking at the figure, we see that F sub p has a downward vertical component, which is going to be proportional to the sine of theta, and a forward or positive x component, which is going to be proportional to the cosine of theta. So when we draw the three-body diagram, here's the x direction, here's the y direction, and here is the block. And it has the positive x component of F sub p, which is F sub p cosine theta. And it has an equal and opposite force in the minus x direction, F sub k. And we know it's equal because they tell us that there is that it has a constant speed, so there's no acceleration. So the forces must balance. Then acting in the plus y direction, we have a normal force. And acting in the minus y direction, we have the weight of the block plus we have the y component of F sub p. And these forces must balance. That is, N going up must equal to mg plus Fp sine theta going down. So that's part A. In part B, we're asked to determine the force due to the friction, F sub k, acting along the block and the surface. Well, we know that kinetic friction is equal to the coefficient of kinetic friction, mu sub k, times the normal force. But we also know that it's equal to F sub p cosine theta, because the forces are balanced in the x direction. So we just use the numbers that were given for F sub p, which is 60.0 newtons, times the cosine of 25 degrees. And then when we calculate that, our result is 54.4 newtons. Then in part C, we're asked to find the coefficient of kinetic friction. So now we know what F sub k is because we calculated it in the previous step. And we know that F sub k is equal to mu sub k times the normal force. So mu of k is equal to F sub k over the normal force. So that's F sub k over mg plus fp sine theta, since the forces are balanced in the y direction also. Then just putting in the numbers, we have 54.4 newtons in the numerator from part B. Then the mass is 30.0 kilograms. Times 9.80 meters per second squared, plus F sub p sine theta. So let me move this down here so I can fit it on the page. So F sub p is equal to 60.0 newtons. And then we're multiplying that times the sine of 25.0 degrees. And then we carefully put that in our calculator. And we get a result of 0.170 for the coefficient of kinetic friction. And that's the solution to problem number 1.